I'm going to give you an overview of ad tech and what happens when you see things on your advertisements, on your applications or your websites. Then I'm going to talk about a real-time-ish campaign reporting. That's the most important part. And then I'm going to give you some Uncle Pete's advice. And because I'm so old, I'm Uncle Pete. So how big and how fast in ad tech? When you talk to your mother about what you do, how do you explain to her what it is you do? There's a generational gap there. It's a concept people don't understand, so you want to give people a frame of reference to talk about how big and how fast. So if we talk about bytes, if we said 1 byte is equal to 1 second, a petabyte is 34 million years. And let's talk about latency. The human beings, a blink of their eye is about 200 to 400 milliseconds. So in my company, in Adform, we have between 270 to 370 million years of data. That's depending upon the time of the year and the time of the day. And every time you blink your eye, we receive between 900,000, 1.7, 1.8 million bid requests every second, or every time you blink your eye. So in a second, we do about 7 million of them. So this gives you an idea of how to describe latency, throughput, and scale. As a global infrastructure, as a medium-sized ad tech company, we have 9 data centers all over the world. For obvious latency reasons, we have gazillions of real machines, physical servers. We've got petabytes of HDFS storage. We have many VMs, too many VMs, a large Kubernetes cluster, big Aerospike usage, lots of network bandwidth, fantastic usage of our Nginx load balancers. So everything we do is big, fast, and high volume, to put it into scale. So how do we do this? First of all, we have 3 kinds of data. We have fast data. This is the kind of stuff that has to happen in a millisecond or 2. And there are usually millions of these kind of data operations every second. So we use Aerospike for that. We have about 22 terabytes of data inside of Aerospike in several different clusters, different use cases. The average latency of a query, so the average latency of a read or a write, is about 0.9 milliseconds. And that's to persistent storage. That isn't just into RAM. Our biggest set is about 9 billion rows, which are 9 billion cookies or user profiles on all of you guys and me and everybody else we can find in the world, advertising profiles. And we do about 11 million operations per second. Every second of the day, every day of the week, every week of the month, every month in the year, and it gets worse about this time of the year. The last quarter leading up to Christmas is absolutely disastrous. Everybody's on tenterhooks, nobody goes home. We all make sure that we've greased all the joints in the steam engine that runs all of this, so that nothing breaks down when we make the most money in the year. We have a lot of analytical data. So if we have some data scientists here, you'll know that you love lots of data and you'd like to do some really curious things with the analytics. So we use Vertica for that. Vertica horizontally scales out and allows us to have massive amounts of reasonably slow queries. So we've got 250 terabytes of that there. The latency on this kind of a request is half a second, not a millisecond. And we do several thousand of them. We have more rows though, many more rows in the side, maybe 10 times as many. And then we have the ubiquitous data lake, or the data ocean that marketing people call it. I call it a data swamp because it's full of all those icky things that you find in a swamp. It's got some lovely insights in it, but essentially it's a big bucket of noise that we search through to find the signal. We have about 10 petabytes of client campaign data, so data that's related to an advertising campaign or to the people who have participated in that campaign. We have about 10 petabytes of that alone. How much do we actually store? Depends how much we can actually afford. As you know, 10 petabytes means there's physical machines somewhere in the world with the data on it. And we clean that up. We keep about 11 to 13 months worth of data in one period of time. And it's raw. It's absolutely raw data. So if you think of the information hierarchy where you have information, you have knowledge, and you have wisdom, this is definitely just information. I'm going to give you an overview on real-time bidding, and this is the heart and soul of advertising technology. So you go to your favorite website. So I've gone to Stack Overflow here. I'm interested in the articles that are written over here. And there is some advertising just here. Why is Stack Overflow free? Because the publisher of the website sells this advertising space to an advertiser, and that's how they make their money. What happens in this simple scenario is that this ad is kind of what you're interested in. Not like television where you sit down and you're watching, I don't know, whatever boring television program you have, and you get an advertisement with a catchy jingle that makes you go out and buy chocolate or toilet paper or something like that. And it's the same ad all of the time. This ad is targeted to you. So this publisher sold this space to an advertiser, just like in a magazine or just like on television. So what really happens? There'll be a short quiz at the end of this, so to leave the booth I have to ask you questions. Just kidding. We have a publisher who you visit their website or you use their app on your phone. The publisher is about to display their web page and they have some space to sell, so they go to an advertising network. The advertising network goes to a sell-side platform or a supply-side platform, and an auction starts here. So this space is auctioned to a bunch of bidders. The demand-side platform receives the auction. It's a bid request that says, we have somebody at this location in the world with this cookie or this advertising ID. Are you interested in making a bid? So the demand-side platform receives the bid, looks through their profile of who they have and what campaigns match that person, responds with the bid, and if they are successful, the auction service tells the bidder service, okay, you've won, give me a tag for the website so that we can display the ad. That cycle happens in about 100 milliseconds. And we receive 7 million of those every second. We run all of this, by the way, on essentially commodity-priced hardware. So there isn't Teradata sitting in the background and Craze doing all the number crunching. This is just the standard sort of stuff you'd find in any cloud. This happens all of the time. We bid on 30% of the bid requests we get. The others we say no bid. We win about 3 to 5% of those. The advertiser pays the publisher through our network, so we have to handle money. And we, like all good business people, we skim a little bit off for ourselves. We hold a little bit back for ourselves. That happens all of the time. That's the modern world. If you are unaware of what happens when you use the internet, this is what happens. Why are all those things free? Because advertising pays for it. So, That was a wonderful introduction, but what I want to do is talk to you technically about how we do real-time campaign reporting. So if you're a campaign manager for an advertiser, you want to know if you've selected the correct demographics, the correct locations in the world, the correct time of the year. So you want feedback as quickly as possible so you can modify the ad, modify the campaign. And so I'm going to show you what we can do with real-time campaign reporting. So there's two kinds of campaign reporting. There is the stuff and the slow stuff. And when I say slow, it might take 5 minutes for the report to run. It might take 10 minutes for the report to run. And that is where people want to get this massive, huge spreadsheet with all of these statistics that pop out of the bottom of it. And they do some kind of cunning analysis to see if the campaign works. Or they bullshit to their boss that the campaign works. Okay? Well, what I want to talk about is the fast reporting. This is where it's real enough time for a human to see the change. So in about a second or so. So example of this is you might have a bunch of metrics on a screen someplace that will be updated in front of the user to show the change. Distinct differences. I'm not talking about slow reports. There is about 1 million people out here who can tell you every cool way of generating a report from data. I'm just going to talk about this fast stuff, where you want this less than a second, real-time-ish statistics. So this is what really happens. When you have this web page and you click on it, or you get shown it, sorry, this thing is called an impression. It's been placed in front of you to give you an impression of what's available to buy. So if you view this, or if you click on it, or if it's a video, you play the video, part of the video, the whole video, you fast forward it. If you then visit the vendor's website and you like what's there and you make a sale or you make a conversion, all of these are events that are recorded for campaign reporting. And they flood back to something. So if you have a look at this simplified sequence diagram on the right, there's all of these events that flood in as a result of serving an ad. And all of those events have to be captured. So every time you serve an impression, you get statistics back. You'll get at least one back, and you might get a whole set of them back. So this is what you use for your fast reporting and, of course, your data science. You capture all of those things to give you more information. So the obvious way to do this is to build a set of event collectors that live geographically located strategically throughout your market space. So if you're selling to the whole world, you want some kind of event collectors distributed all over the world. So this is the simple kind of thing. They're brain-dead web APIs, RESTful or not RESTful, and all they do is collect events and they concentrate them and feed them into some kind of centralized core campaign service that puts these events together into statistics. Very simple. That's one way of doing it. There are obvious limitations with that because you then eventually have these dotted lines become very big fat pipes of data flowing continuously, and that costs you money. Another way of doing it is you can add some kind of data store on the edge of your collection point of view, which serves as a buffer, which serves as a place to capture the raw event and then funnel that from the data store towards a centralized core storage. Once again, these diagrams are super simplified. You'll have 1 million questions about, but what if, but what if, but what if. What it does is allows you to collect events in 1 or 2 milliseconds instead of taking longer. It allows you to have fewer event collectors and fewer, smaller pipes between the edge and the core. So you save some time. The event collectors don't have to be very sophisticated. They can be a availability and partitioning style configuration where you capture the events and then you feed them through. So one way to do this, to add to it, is that you have to have a real-time aggregator in the center of the core. So if you look, forget about the words on the screen. I put them in because marketing said I had to. If you look at this situation, we have a publisher who sends an impression event to an event collector. There is your brain-dead web API, drops that into a data store. The data store that I like to use the most is Aerospike. It's really good at that row-oriented problem. High velocity, low latency, row-oriented problem. Using the Kafka connector that comes with Aerospike, at some time after the event is stored, you suck those events out of the database and you put them into a small Kafka cluster. Small, meaning that you can have if you have an event store, no, I'm sorry, not an event store. If you have an event data store, to be distinct from the product, you can have a smaller Kafka cluster. Then you have an aggregator that reads from that and does the aggregation or the reduction of data from single events into statistics that you use. These statistics might be a simple counter, they might be a histogram, or they might be a standard distribution, standard deviation, all of those things that everybody wants to do. And you would code that in there. That could be something like a Spark job, or it could be just code. Now the campaign store itself, once again I like to use Aerospike for that, because built into Aerospike is a document style structure. So you can build the metrics and the dimensions for your campaign statistics and put them in a document structure, and using the complex data type operations, you can update the individual elements of the document in about a millisecond. So you don't have to read the whole document, do something to it, then write it away again. So this is a simplified object diagram that describes the way you would have things related in a campaign. So a campaign, somewhere out here is an advertiser, and you have a campaign, it has a start and an end date. You have one or more execution plans. In the industry, sometimes these are called line items, and sometimes they're called placements, but they're essentially a portion of the campaign that gets executed in a certain location at a certain time. So you want to have something where you can maybe update the number of clicks that have occurred in this execution plan, or maybe the number of views, or the number of conversions. And so the event aggregator and reducer can combine these values together and increment counters, increment values in histograms using the Aerospike campaign complex data type mechanism. So, why Aerospike? I'll tell you about why Aerospike in a minute. So, I've talked about Aerospike as the data store here. Our user profile store is huge. 8 to 12 billion records, depending upon the time of the year. So we either have 2 records for every human on the planet, or 3 records for every human on the planet, depending what's going on. Throughput's about 1 million a second. Latency is about 0.9 of a millisecond. Sometimes 1.1 milliseconds, but mostly point that. And that's, in the CAP theory, that's availability and partitioning. It's got to be always up, it's always got to be available. We're not so concerned about its consistency at that point. The event data store is a similar one. We will have 40 to 80 million records in that event data store scattered around, representing all of the campaigns that are running, the events that are flowing through. Once again, a low latency but not nearly the same amount of traffic. And that's that edge data store that captures the events. And then the campaign data store is kind of related to the number of campaigns and execution plans you have. Once again, not a huge amount, 40 to 80 million. Throughput is 200 to 300,000 a second, so much smaller. Latency is still low. So we can update a counter in a millisecond. So we can increment and read a counter in a millisecond. So, Uncle Pete's advice. You get Uncle Pete's advice because I'm old and I've got grey hair. And if I look around the room, I think I'm older than everybody here. So why do we use Aerospike? Advertising technology makes money every time we win a bid request. If we can't bid, we can't make money. If we're down for an hour, that's not quite €1 million that we lose. So it's a big amount of money, which we can never recover. So we need something that has low latency, huge capacity, high throughput, and high availability. It's always got to be there. We used to use something else in Adform, and we had a cluster with 150 nodes in it. And, well, I say 150 nodes, there was always some of them that were broken. If you have 150 of anything, some of them aren't going to work. If you have 150 people, you're going to have some of them that are going to be sick or on vacation or dropping their kids off at school. Not everybody's going to be at work at the same time. So if you have 150 nodes in a cluster, some of them are broken. So honestly, I would say we never knew how many nodes were working in the cluster. So we went from that to Aerospike. We went from 150 to actually 8 nodes and then eventually to 12 nodes through expansion. Now, while it's very heroic to have 150 nodes, it's more practical to have only 12. So it's easy to use, it's value for money, and it works as advertised. So we save money and time and heads and heartaches and people getting out of bed in the middle of the night to go and solve a problem. And we eliminated garbage collection issues associated with JVMs and database segments or data partitions being offline because of that. So we saved time and money. The other thing, everybody likes to talk about open source versus an enterprise product. And at Adform, we had a choice to use Aerospike as our primary cookie store with the community edition or the enterprise edition. So the community edition is open source. It is free, essentially, so long as you don't value your own time and you've got 10 or 15 people who are going to look after it the whole time. But if you do open source, fork the source repository yourself, build it yourself, and know how to survive on your own. Why? Because the producer of the open source may disappear sometime in the future. So we chose enterprise. Okay, it costs us money. It costs us real money, but we make more money because we have a neck to choke. We can call somebody and say, that new release you gave us does not work. And they go, oh shit. Oh, I promised I wouldn't say shit or fuck during this presentation. We go, oh, and then they run around and they fix it for us. They find out the solution. So we've worked out that Aerospike's probably cheaper than it would cost us to run the open source equivalent. Any questions I can answer? All right, then, thank you very much. I appreciate your time.